What are we going to cover today? Well, we are going to cover today the concept of workspace design. So what is workspace design all about? Well, a basic workspace, as we found over the last couple of days, is how we translate data in FME. We read data in, we transform it, we write it out. Read, transform, write. Another way of looking at that is sometimes it's called ETL, extract, transform, load. But that's what we've been doing up until now. But there are more advanced techniques for directing data through a workspace. You might want to read some data, write some data, and then do something else. You might want to include a web service, something like that inside. You might want to read data from lots of different formats all at the same time, or test individual parts of a workspace. So this is what we're going to cover today, this whole idea of workspace design, how you can design your workspace to be more effective and to include lots of different other components in there. And the first thing we're going to talk about is prototyping. Really, prototyping normally means creating an incomplete application. So we're just sort of putting something together to see if a project is feasible. We're going to stretch that a little bit and say, well, we're going to build our FME workspace in little sections at a time, building it incrementally. And we're sort of going to call that prototyping, because you're prototyping each section of the workspace before you use it for the final project. And you build your workspace bit by bit. And this, once you become more familiar with FME, you'll find that this is the way that really it works. You generally build all of your workspaces this way. And the key concept of that is this idea of incremental updates. The steps for that would be, well, plan your project as a series of sections, each of which would fit inside a bookmark in FME. Ideally, each section is between, say, 3 to 10 transformers. It's not definite, that's an arbitrary number, but once you get more than 10 transformers in a particular section, then it becomes more hard to understand what's going on. And in fact, a lot of our demos that we do with FME, we try and keep it to under 10 transformers per demo, otherwise it just gets a bit more complicated. So 10 transformers is the point at which you say, well, let's chop that into smaller sections. And so what you do, you plan it out, you design it in your workbench, you create each section, and then you run it and test it straight away. And that way you're identifying problems at an early stage, and you can identify where they are because you've just added that particular section. If you added the entire workspace, you created a workspace that had 50 or 60 transformers, and then you run it, well, okay, that's it's more likely to have problems, and it's more difficult to figure out where those problems would be. So the idea here is put a little bit of workspace down, run it, and see if it works okay. Source data is interesting for this. When you've got a large project, it's likely that the source data is going to be large as well. You don't want to create your workspace a section at a time, testing it on that entire data set. If you've got 1 million records that are all pretty much the same, you probably only need to test it on 100 or 1,000 records. And once you know that works, then you can run it for real in production. So it's sort of this idea of, well, authoring and testing versus production. And really we're looking at authoring and testing at this point. So what you can do with your source data is you could say, well, let's take some of my source data, read all of it into a workspace, and then split it up into little bits. Maybe you tile it into spatial tiles. Maybe you use a sampler, just create a sample of that data. And then you write it out to a format like FFS, which is FME's own internal format. So what I'm saying there is read a sample of data, write it out to an FFS file, and then use that as your source sample data set when you're creating your workspace. And when you are creating your workspace, version control is another interesting thing. We don't have quite yet a full system control, version control built into FME. That's one of the most requested enhancement, so I think it will happen at some point, but for now we don't have that. So what you really need to do is create your workspace, save it under a version name like Workspace version 1. Then next time you come back to make some more changes, update it to version 2. Why would you do that? Well, because it's easier to track changes because you've got a record of what's changed and when. You can create different versions for different platforms. You don't lose the entire project if the workspace gets corrupted, or you password protect it and forget the password and I can't open it again. So you keep different versions of your workspace to make sure those sort of things don't happen. And it's not just a workspace, you should really be keeping backups of your Python and log files and source data sets and everything. So just a few tips there on running a project with FME. And as it says at the bottom, even if you don't have FME Server has a version control built in, and you can use that even if you don't have an FME Server license. So you could download FME Server from our website, install it. You couldn't use it for running translations or distributing data, which is the normal use for it, but you can use it as a repository for workspaces and version control, and you don't need a license to do that. So let's go on. So we're starting our workspace, and there's a key thing that happens in a workspace is you'll find that a lot of transformers have a rejected port. Basically, something happens in that workspace, in that transformer, and the data is rejected, and it comes out of this rejected port. Excuse me, I'm just pouring my tea into my mug. So if you hear a trickling noise, that's what it is. We're not flooding. Okay, so we have rejected feature ports in a workspace. Let me open up a workspace so I can show you an example of this. In your FME data folder workspaces, there's an instructor use folder, and all of the demos and screenshots in the manual should match up to workspaces in here. So let's see, what chapter are we on? We're on chapter 3. So incremental design, rejected features, there we go. So I've got a workspace that will show that. So what are we reading? Well, we're reading some bathymetry data. It's contours and points representing the depth. They're going into an intersector transformer, and the data is going to get rejected there because the intersector doesn't work on point features. So what we're going to see here is data being rejected by that intersector, like so. I'm just going to increase the font in my log window so you can see canvas annotation font. Where's my log font? I know there's a log font in here somewhere. Okay, well, let's not worry too much about that. Anyway, so a feature got rejected by that transformer. What happened when a feature was rejected? Well, it output it there and it immediately stopped the translation. So rejected features by default stop the translation. But there are different ways we can handle that. One of the things we can do is say, actually, I don't want to stop the translation. I want you to carry on with that translation. And the way we can do that is looking in the navigator window. There's a section of parameters in there called workspace parameters. And under translation, there is a parameter called rejected feature handling. And if I double click on that, I can change it from terminate to continue. So what that means is now we're going to continue if we get any rejected features, and we'll run the translation and it rejects all of those features, but it carries on processing the ones it can. So you've got that idea there that you can either stop the translation or you can continue it. And that totally depends on what you're trying to get out of the workspace. Sometimes you might want it to stop immediately, that there's a bad feature because you don't want to upload, say, bad data to your database or incomplete data. On the other hand, sometimes like this, you could say, well, Doesn't really matter if point features don't get intersected because that's sort of expected. So we can just turn that option off and say, nah, continue the translation. That's fine. So you have that option there, continue or terminate the translation, whichever way you want to go. Now the other option you can do there is you can make it a bit more mixed. So if I flip this back to terminate translation for a second, because the problem with changing it there is it affects every different transformer in your workspace, and there are lots of transformers. In fact, every transformer in here apart from one has got a rejected port, like the coordinate extractor there was rejecting features as well. So what you can do is sort of have a mixed mode, like you can say, well, I'm going to terminate everything in general, but if I know something's not going to be a problem, like the rejected port on the intersector, I can do something with that output. And if I do something with it, FME won't reject, it won't stop the translation. So for example, I could connect that to a logger transformer, or even just put a junction in there. A junction doesn't do anything, it just sort of collects data. So what I'm saying there is, well, in general, stop the translation if something's rejected, but for this specific transformer, I know it's okay. So just sort of write the output to there and forget about it. And if I run this translation now, what will happen? Well, the data there gets rejected and it's okay. But when it gets to this transformer, it gets rejected and it's not okay because we're in terminate mode and I haven't done anything with it. So basically, this is another way of creating your translation. You design it a bit at a time, you run it a bit of a time, and you handle what comes out of the rejected ports when you need to. So this is all about designing your workspace. And you can see the numbers show me how many features come out of the rejected port. Like here it was 891. If I've set it to terminate mode, then as soon as the first one feature appears, then it will be rejected immediately. Only one feature. So yeah, the numbers mean something. They'll tell you about how many features are rejected. And you get this option to say, well, globally, I'd like to sort of carry on, or globally, I'd like to terminate. But at the same time, for a particular transformer, I can turn it off by just connecting that to something. Natalie says, translation, general log fonts. Is that tools, options, translation, general log font? There we go. Why that doesn't appear under appearance with the other fonts, I'm not sure, but I just wanted to increase the size of my font in my log so that you can see the error messages a bit more clearly. So that's what we're going to do there. Thank you, Natalie. That was very useful. Let's see. Okay, well, we've got an exercise to do. Excellent. So this gives you something to do instead of me just talking all the time. So what we have here is an exercise that's all about residential garbage collection. If you've looked at any of the data that we've had already, you might have noticed we have an Esri Geo database, which is a spatial data format. And in there was a set of data for garbage collection zones. So there were 5 different zones on each day of the week. Certain garbage collection gets carried out. But if we look at the number of addresses in each section, we can see that actually it's not very even. Like Tuesday, there's something like 5,000 addresses to collect, whereas on Monday there's only 1,000, and obviously that's not great. So what we're going to do is we're going to try to draw up new boundaries that are a little bit more equal. So that's sort of our scenario here, but really what we're looking at is how we can create this workspace step by step, testing each step at a time, basically doing it in a workflow that actually makes sense. And we're going to learn a bit about how to create workflows in FME in a good way. So we're going to create these new boundaries. We're going to create 5 polygons with roughly the number of same residents. But we're going to take zoning into account and say, well, if it's a single family residence, then that'll have 2 adults in it. 2 family residents would have 4 adults, and so on. So we need to get some zoning data in here as well. And the output's going to be in this geo package format. So let's just scroll down that exercise, and I see Natalie has chatted out the link to that. So please go to that link and have that open and have Workbench open at the same time. So I'm going to open up the starting workspace. So File, Open, or just the Open button, and it's Workspaces, Desktop Basic, and it probably comes under Design. That's it, not Workflows. Design Exercise 1, Begin. So let's open that up. So what we've got here is a sort of prototype workspace to carry out this task. The person who created this has sort of split it down into different sections and say, okay, well, I'm going to need addresses. I'm going to need to join it to the zoning data. I'm going to calculate how many residents are in each zone and create boundaries around it and create a group and then write the data out. And we've got a sample addresses bookmark in there because we'll probably want to sample the addresses to make it a smaller amount of data just to start with. And all the transformers that we think we're going to use are in this bookmark at the bottom, including the sampler, this point on area overlay, a statistics calculator, and so on. There's lots of different transformers there. So you don't need to know what transformers we're going to use in advance. They're all already in there. One of the things we can do, by the way, is, let's make sure that caching is turned on our machine. So on the Run button, we've got prompt turn on and we've got enable feature caching. I don't know about prompt, we could turn that off, but we do want feature caching. And what I'm going to do is hit the Run button now, and what that's going to do is run and just read the source data into the postal address feature type. And while it's doing that, I can start looking down the next step, which says put the sampler transformer in there. So I can drag the sampler transformer up into where it says sample addresses, that bookmark there, and connect it up like so. And you see by now the address reading is finished, which is all good. So what we're going to do is we're just going to sample the data as it comes in. We're not going to create a separate test data set. We're just going to sample that data. And I'm going to open up the sampler parameters. Again, you should be familiar with this from yesterday with transformers. They all have parameters. We can click on the cogwheel button. Here it is, and in fact it's already set up, and it says sample every 25th feature, which is great. So that means we're only going to use 1/25th of the data, and we can run this transformer now just by hitting the run to this button on it, just to make sure that works. And again, this is an example of step-by-step run, set something up, run it, set something up, run it, make sure it works. Sampling looks like it works. We've got 543 features sampled, 13,000 features weren't. Yeah, that looks about 1 in every 25 features to me, so that's all good. Okay, so we should have a reader, we should have a sampler transformer in there, and it should be looking like that. So what we're going to do now is we want to divide the data up into groups. We want to split it up into 5 groups, and we're going to want to do it in a spatial way. We can't just say, let's pick all of the addresses and divide it into 5, because we might end up with addresses in one side of town mixed in with the same group as addresses on the other side of town. And that wouldn't do. Obviously, the garbage truck would be going backwards and forwards. So what we want to do is create groups that are spatially adjacent to each other. And we have a transformer that can do that. It's called the Spatial Sorter. The Spatial Sorter transformer is green because it's a custom transformer that you can find on what we call the FME hub. The FME hub is where extra transformers are made available now and then, and to add extra functionality into FME, and this is one of them. So we'll put that into the workspace under divide residence. That's going to split our data up into 5 different groups. Now let's have a look at the parameters for this. The parameters say, oh, group size. So it's not telling us how many groups do you want. It's saying, well, how big do you want your groups? Well, we don't know how big we want our groups because we don't really know how many features there are. And even if we could hard code that number from looking at the numbers on screen, hard coding something's never really that great, because if the address database changed, we might have a different number of addresses. So we need to calculate the size of the group that's coming in to this transformer. So basically it's going to be the number of addresses divided by 5. So let's figure out how we can do that. So what we can do is use a combination of the statistics calculator and the expression evaluator. What's that going to do? Well, the statistics calculator is going to tell us how many records we're reading, and the expression evaluator is going to divide that number by 5, and that will tell us how many addresses we have per group. So I'm just going to move this bookmark across and expand this bookmark a bit, which I can do by just clicking and dragging on the edge. And we're going to put the 2 transformers in here. Again, we know where they are. They're down in the bottom. So statistics calculator, we're going to drag that up. And the expression evaluator, we're going to drag that into there as well. So we're going to connect the statistics calculator to the address data. For now, just the sampled address data. In the future, we'll do it on all of the addresses. So we connect like that. Connect the complete data from the statistics calculator, connect it to the expression evaluator, and then that can go into the spatial sorter, like so. So that's how we're going to connect things up for now anyway. Again, as you'll find, workspaces grow sort of, I was going to say organically, I don't know if that's the word to use, but I guess it is. You do something, you try it out, it works, and then you sort of figure out, well, actually, I need to do a little bit else as well. So we go back and change something different. And that's pretty much what we're doing here. So we've added those transformers in. Let's open up the statistics calculator. What we need to find is, we need to find the attributes to analyze. So what we're saying here is, well, you saw this yesterday with the dog parks. We analyzed the area. What are we analyzing here? Well, we're not really analyzing anything. We just want to know how many addresses we're getting in. So let's just browse and pick any attribute. And the one at the top happens to be country, so that's okay. We'll just pick that. And we don't want the minimum and maximum, because what's the minimum and maximum of the country, which is Canada? It doesn't make sense. All we really want to know is how many records are coming through, and that comes under this total count attribute. So that's the only one we want. And as the manual says, I'm going to change that to be an attribute called total residents. So that's how many addresses we've got coming through the data. And now we just have to divide that number by 5. So if we had 1,000 addresses and divide it by 5, we could say, hey, there's 200 per group. So we're going to look in the expression evaluator. So hopefully everyone's up with me at this point. If I'm going too fast or even too slow, please do let me know, and please ask any questions that you want of Natalie. So we open up the expression evaluator, and what does it say in the manual? Well, the first thing it says is to, so what happens in the expression evaluator is you carry out an expression in here, a numeric arithmetic expression, and it puts the result into an attribute called result. First thing we're going to do is change that attribute to be called group size, so it just makes a bit more sense. And we are going to put the expression in, and the expression is going to be the one that's in the manual. And I think I can copy that and just paste it directly in here, which makes it a lot easier. Can I change? I don't think I can change the font in here, which is a bit sad, but I can't make that any bigger, so we'll just have to leave it. But basically the expression there is to say, take the value of the total residents and divide it by 5. What does that ceil function do? CEIL. Well, that's a ceiling function. That says basically round up. So if we had 1,001 residents divided by 5, rather than trying to say what is 20.1 or 20.2 residents, we would say round it up to 21. So we're going to do that. So basically round the value up when you divide it by 5. And you can see in the expression evaluator, there's ways to grab attributes and bring them in. There's a way to grab string and math functions and all sorts of things like that. And yes, you'll need to get used to that in your future FME use. But for now, we can just copy and paste that expression directly into there. And so what I can do now is just run it up to that part, just up to the expression evaluator. So I click on the expression evaluator and say, run to this. And now I've got all of my data cached. So if I inspect what's coming out of the complete port, I've only got a small area at the bottom of here for the visual preview, but that's okay. I don't need any more. All I need to check is that we have a total residence, 543, which is the same number as on that's going into out of there, so that's all good. And the expression evaluator, I can click on that and see what the data's like there, and we should find that group size is 109, which is 543 divided by 109, rounded up. Couple of questions there. To make the text in the expression evaluator bigger, you can control a mouse wheel, really? Huh, so you can. That is very useful. I wonder why we don't have that option on there, but thank you for that. That's superb. What's the function on here? So let me construct this expression from scratch, and you'll see how it works. So really, we've got this math function down here. We've got a list of math functions like sine, cosine, tangent, int, log, max, min, etc. What we're trying to find is this function called ceil, C-E-I-L, which rounds things up. Now, there's a sort of art that you learn about which order you add things in to this dialog. I'm going to go with this function first, so I just put there and say ceiling is, I want to round it up. What do I want to round up? Well, that's the float part, which will be, find the attribute, total residence divided by 5. What's this precision thing mean? Well, it means how many places am I rounding off to? Well, I'm just rounding it up to nearest 1, so we can just delete that. So there we go. We've got total residence divided by 5 and find the ceiling of that. And you'll see in the manual there's a couple of extra brackets in there. That's just because when I write these out, I tend to get hyper cautious about that. So we've got extra braces in like that. So anyway, so we have that number. It comes out of the expression evaluator. We had 543 residents divided by 5 and rounded up gives us 109. So now what we can do is look in the spatial sorter, which is step 6, and say the group size is, I guess I could type 109, but really that's hard coding. We don't want to do that. I'm going to click drop down, attribute value, group size. So now it will read that. And so if we suddenly had more addresses or fewer addresses, or we sampled more or fewer, then it wouldn't matter. It would totally be handled in here. That's one of the differences between hard coding things and using FME attributes to define them. We could run that right now. I can run that spatial sorter. And we have the 543 records. And you can see them in here. And there they are. And if we look, we should find that there's a group ID number on them. So that one has a group ID of 2 and the other one had a group ID of 1. What we're going to do though is we're going to actually group them together with this aggregator transformer. So I'm going to drag the aggregator from this bookmark. I'm going to drag it up to this bookmark up here that says group residence, and I'm going to connect that up to it. Open up the parameters for the aggregator. What the aggregator does, it basically creates multi-feature, multi-geometry features, like multiple points in a single feature. And what we're going to do is hit this group by button and say, okay, well, group by the group ID value. And what that means is for every separate group ID, you'll get an aggregate of these. You'll see by looking at the output better than I can explain it. So I'm going to open that up in the data inspector just to make it a bit more visible. So there are my addresses. They're all divided into groups. How do I know? Because if I click on one of them, oh look, it highlights that group of addresses. There's another group of addresses. There's another group, another group, and another group. So we pretty much got a long way through this exercise already. Excuse me. So yeah, we got a long way through this already. We have basically find our addresses and divided them up into groups. Now, they don't look very good groups for a garbage collection, but remember, we're only working on a sample of the data. So, well, when we sort of push the full data through, it'll get a bit more accurate. I see someone was having problems there. The paths in a pre-created workspace are incorrect. It shouldn't be. I guess it might depend on whether. Okay, so that might depend on when you created your virtual machine, because maybe there was. Depends if you're using a virtual machine or your own machine to download the data. If you're using your old machine, I guess you might have an old version of the data. If you're using a new machine and it's if you're using a virtual machine and you created it earlier this week, maybe we made some changes and fixes. Basically, the way to fix these will be to look in the navigator window, find where your source is coming from, double click it and change it from 8 to 9, and that should do it. But I've just mentioned that, and hopefully it won't be too much of an issue. Okay, so that is pretty much, pretty much that exercise, I think. We could throw an inspector transformer in there, but I don't think I necessarily need to do that. So just to run through that again, what did we do? Well, we put the sampler transformer down just to work on a smaller amount of data. We put the spatial sorter down to divide the data up into 5 groups, but we found that the attribute it wants, or the number it wants, is the size of the group, which we didn't have. So we had to calculate the size of that group. And here we sort of anticipated that because we had the transformers ready for you. In real life, you probably wouldn't. You'd have to think about that again. So statistics calculator, we told us how many features there were. The expression evaluator divided it by 5, rounding up. And then we told the spatial sorter that's how many features are in each group. And the nice thing about that and not hard coding it is if I went back to the sampler and said, actually, I want every 20th feature, it would still handle that fine. Now, a couple of questions there. Can we repeat the aggregator parameters? Yeah, so what the aggregator does, like I mentioned, it's going to take all of those points and create them, sort of smush them all together into a single feature and say, this one record is comprised of all of these points. And what I did there, the only setting I changed was in the group by mode and said, actually, don't create a group out of everything, create a group out of the separate group IDs that we've just created from the spatial sorter. So that's what we're doing there. Where hopefully you remember yesterday you did the group by parameters, and if you don't do that, then everything gets created as one aggregate. But because we've said, hey, use this group ID, there were 5 groups, 1, 2, 3, 4, 5. So it's created as 5 different groups of features, and we can see that in the data inspector, like so. Now the other question that came is, could we give them different colors to make it more obvious? Yes, we could do that. We could put an inspector transformer down, because the thing is with a visual preview, see, the inspector has a group by setting, the visual preview window doesn't. So what I could do is put an inspector transformer down and say group by the data. See, we can't just change it in the data inspector because they're all in the same group. So we could change the color of everything, but we couldn't split it up and have them each a different color. So I put an inspector down, did the same group by as in the aggregator, run that translation, and now we should get different colors per group. And they're not very clear colors, but what I can do now, I've got the data all split up, I can start changing those colors in here and say actually make group 1 to be red and increase the size of the points so I can really see them. And group 2, I'm going to change that to be green and do the same thing, and so on and so forth. So you get the idea. It's actually nice to do that in the data inspector because you get a bit more canvas to work with than just the visual preview. The other thing about the visual preview is if you did split it into groups and change the symbology, if you click away then click back, you've lost that symbology. So it's better to do that in the external data inspector, I think. But yeah, the inspector transformer will do that. If you really want to give them your own colors inside the workspace, there's a feature color setter transformer that you could do. And you could say, actually, color them with a random color based on this group ID attribute. And it should, I think, give you a different color per, let's see, yes, there we go. We got beige and blue and violet colors and so on. So there's a few different ways you can do that with the inspector or the feature color setter. Okay, so that's the end of that exercise. Hopefully you are up to speed with that. If you're not, then just try opening up the closing workspace of that. And so the final, so open design exercise 1 complete, and I'm hoping it should be okay if you open that up. Okay, so that was looking at prototyping a workspace, building it step by step. And we keep this workspace open because we're going to continue building on it in the next couple of exercises. And what we're going to look at now is reading and writing workflows. In specifics, we're going to look at how you can have multiple readers and multiple writers in a workspace. Because everything we've done up until now, we've just said, well, let's read from one data set and write it to a different data set. Basically, that's not going to be always the case. Sometimes we want to read from 2 data sets, write to 3 data sets. They could be the same format, they could be different format, they could be all sorts of things. So we're going to look at that. We're also going to look at integrating things like the Dropbox connector, email, basically transformers that integrate with other systems or web services. So we're going to look at that now. So, Workspace components. Well, what are these components we've been talking about? I've been talking about readers and writers, but do we really know what a reader and writer is? Well, let's have a look. I've got my instructor workspace again. Let's see, readers and writers. So I've got a workspace here. No, that doesn't look like what I wanted. I want design components, that's what I want. Okay, so we've got a workspace here and it's got lots of these brown objects on there, which we know are feature types, which are tables or layers. I've also talked about readers and writers. And what are those? Well, a reader is an object that reads data. A writer is an object that writes data. Okay, fairly straightforward. Where do you see those in a workspace? We don't see them on the canvas. You see them in the navigator window. If I look in the navigator window here, I can see, oh, I've got the Geo Database reader, which is reading 3 different tables from that database. And every time I click on the reader, it highlights the tables or feature types that belong to it in the workspace. I'm also reading from an AutoCAD CAD file, and we've got 3 layers or 3 layers from my CAD file are being read there. On the output side, we've got an Excel writer, only one object lit up, so we're only writing to one sheet in our Excel spreadsheet. We have a GeoTIFF writer, that's writing the data out as a raster, and that's a different writer. And the shapefile, which is another GIS format but vector, well, it's got 2 objects highlighted. So I've got, let me see, what have I got in this workspace? I've got 2 readers. If I look in the navigator window, I've got 2 readers, and I've got 3 writers. And the little icons in the navigator window are subtly different for readers and writers. So I've got 2 readers, 3 writers. They're each reading and writing different numbers of tables and feature types. So we have this relationship, and if we look in the manual, and I'll just chat the link out so you know where we are. So if we look in the manual, you can see that we've got this diagram in there, and it's a hierarchical thing. So we have a workspace contains the whole translation. We have readers and writers that belong in that workspace. We have feature types, which are tables or sheets or layers or whatever that belong in those readers. And then we have features that are stored in those. So each workspace can have multiple readers, multiple writers. Each reader can have multiple feature types. Each feature type can have multiple features. So it's always this one-to-many relationship that we've got. And that workspace I'm just showing on screen is just an example of that, like so. So let's flip to the next page and have a look at multiple readers and multiple writers and how we can create those. We add them by either just typing the format, or you can click Add Reader on the menu bar, or Writer, Add Writer on the menu bar. Let me see if I've got a database that I can just show. So we have 1 reader and 1 writer in there. So I've generated a workspace up to that point. I've not added any more readers or writers. I can do that by clicking Reader, Add Reader, and saying, okay, I want to read some more data. This looks just like the Generate Workspace dialog that you had before, but now it's only got the reader part to it. It's not got the writer as well. So I can say, actually, as well as this, I'd like to read from an Excel spreadsheet of, let's see, what can I find? FME data. I'm sure we've got some cultural data. Public art. There we go. So I can say, as well as reading that, I'd like to read from the public art, please. And I click that, OK, and it adds a new reader, and it adds all of the feature types that are in there, which are different sheets in my spreadsheet, like so. And I can just sort of tidy that up a bit. So now that's how I added a reader. I click Reader, Add Reader, and just now I'm reading multiple sets of data. And I can connect those in to here. I can connect them up to transformers. I can do whatever I want with that data, just as if it was added by the generate function right at the start. So that's how I can add a reader to my workspace. And I can also add a writer as well. I can click Writer, Add Writer, and say, yeah, I'm writing it out to GML format, but I'd like a plain CSV file. Or maybe even I'd like to write it out to a GPS format like GPX. and I can click OK, and it'll say, okay, I'm going to add a writer for you, and here are all the different feature types that belong to that writer, like track and waypoint, because that's what you get in the GPS format. Oh, is he going to let me move those? Oh, there we go. It was just lagging a little bit there. There we go. So I could say, actually, let's take, I don't know why we've got a bit of a lag on this computer all of a sudden, but I do. We could say, let's take all of the drinking fountains and just route them straight into this waypoint. And then I could run that, and as well as writing out in GML, I'm also writing a GPS file of all the drinking fountains that you could go to. So basically, reader, add reader is how we read more data. Writer, add writer is how we write more data. As well as adding, we can remove them. So if I say, oh, actually, I don't want to write that GPS actually at all, I can find that writer in the navigator window. Remember, writers appear in the navigator. I can right click and say delete that writer, and it's gone. So we can add readers and writers, we can delete readers and writers, and options appear on the menu bar as well to do the same thing. Updating a reader, that lets us update things that have got out of date. So say I set this workspace up, it's reading a community map called Community Map 2017. Well, that's not right anymore. I know we're reading 2019 now, not 2017. So obviously it's been a couple of years since I created this workspace. How do we update it to make sure it's reading the right data? Well, I could just point it, click the browse button and point to the right data set. Or what I could do instead is say, well, there might have been extra tables added or deleted. So let's right click, update that reader, and it'll come up and say, okay, well, what do you want to update it to? And then I just have to point to the new data set that we're going to be using, and it will update the reader to the latest functionality. It'll check all of the tables to make sure they're still current, and we'll point it to the right file all at the same time. So that's what we're doing here. Even though it is very slow to respond for some reason. Here we go. Let's browse to the data set. So all I'm doing is saying this is my new data, and I want to update the reader, and I want to update all the tables just in case they've changed. Maybe they've got no attributes. Maybe there's a, there you go, we lost a table. So there was a table less in the new data set, and now we're good. So we generate a workspace, you get one reader, one writer, but you're not limited to that. You can add more readers, you can add more writers, you can delete readers and writers, and you can update them as well. If you think it's out of date, or you know it's out of date, just right click in the navigator window, update that reader, and it will refresh it to the latest version. So that's how we can do that. Remember, each reader can read a data set, and we have a parameter that points us to where that reader is. So here, for example, if we look in this dialog, we can see it says that's where your data is. In fact, let me see if I've got a different workspace to demo this on. So this is just my instructor demo workspace here. We have one reader, reading feature types, one writer, writing feature types. How do I know what parameters are? Well, we can basically control how that data gets read using parameters, and we can control where it's read from as well. So if I look in the data window, I can see that this reader has got a whole bunch of parameters, like, do I want to strip braces off global ID numbers? Do I want to detect donuts? Do I want to run some SQL before or after I've read the data? So we have a bunch of different parameters that control how that reader runs. Each different reader, each different format has its own set of parameters, which might not be the same for all formats. Like here we've got this, do you want to detect donut geometries? Well, obviously, if I was reading from CSV, which is a plain text format, we wouldn't have that setting because there's no donuts in plain data. So yes, every different format of data has its own different reader parameters to read it. And as it says in the manual, it controls the features and the feature types in the data set. Think of it like brewing a pot of coffee. These are my controls to say how that coffee is being brewed. If I change one of these settings, like I change that from yes to no, then it affects that reader in total, and all of the tables that get read are affected by that parameter. In the same way that if I change the strength control on a coffee machine, it brews it, it puts it in the pot, well, that's affected all of the cups of coffee that come out of that pot. So basically, parameters at the reader level affect every different table, every different layer that you read from that data. And the same thing occurs with the writer parameters. We have parameters that control the writer here, so I can say, if I look at this, we've got output, GML writer. Some of the parameters listed there are what GML version. So I could double click that and say, yeah, I don't want to write 3.1, I want to write 3.2 instead, just to be up to date, and click OK. And we've changed that version. And again, whatever I change in the writer parameters affects every single layer or table that gets written out. So it won't be that this table is written out of version 3.1 and this one's 3.2 and this is 2. If I set it on the writer, all of them are going to get the same treatment. Every single table or layer that's output gets the same treatment. Again, like the coffee machine, every single parameter I set affects that. So we basically like the coffee machine again, each cup of coffee coming out is the same. Now, there are things you can do with your coffee. You can say, well, let's add cream and sugar, and that's separate per cup of coffee. And that's what we call reader feature type parameters, and we'll look at those in a second. So for now, we're going to go back to that exercise that we were working on before, and we're going to start adding more readers, and we're going to start looking at the parameters for those readers as well. So let's go back to that exercise we were working on, which looked like this. And let's carry on working on that. And again, I'll just chat that link out. So here's the exercise that we're on. So open up that workspace, open up the exercise text, and let's run through that. Okay, so we have a project to redefine the garbage schedules. Okay, so far we've used various transformers to divide addresses into 5 separate groups. And we created those groups in the spatial sorter, and you saw the output. It looked like we have 5 different groups of addresses, albeit that they're not amazingly tightly grouped right now. They're a bit spread out in some cases, but that's okay. Now, the other thing I mentioned before that we haven't taken into account yet is the number of people who live at each address. So far, we've just taken the number of addresses and divided that by 5. But really, we want the number of people living in each address. That makes a difference. It makes a difference whether 12 people are living at an address or 2 people. How do we know that? Well, we know from the zoning. So what we're going to do now is add some zoning data in and try and figure out which zone each address falls in, and therefore how many people reside in each address. So we open a workspace, it should look like that. The manual suggests if you saved it as version 1 before, you should save it as version 2 now, which is great advice. I'm just not going to do it because we're in a training scenario, but you really should be doing that in real projects. So the workspace looks like that. We've got 4 transformers left in the bookmark below. But we're not going to use a transformer. The first thing we're going to do is add a reader to read some zoning data. You can see that the zoning bookmark is empty. We don't have any data being read yet. So let's add a new reader to read that zoning data into the workspace. So we're going to click Readers, Add Reader on the menu bar. And again, it looks just like the Generate dialog, except it's only asking for what the reader is going to be, not the writer. And we are going to pick the Map Info tab format, which I find is by typing my tab. We are going to browse for the zoning data. So I'm going to browse to FME Data 2019 Data, Zoning folder, and zones.tab. And that's what we're going to add. We click OK. Now look in the navigator window as we do that. Oh, look, we've added a new reader in the navigator window. So before we just had one reader to read addresses. Now we've got a reader that reads zoning data. That reader is only, that data set it's reading has only got one different layer of data in it. And we're going to drag that into here so it's part of our workspace. Now what I can do now, it says actually create a spatial join, but what I can do is if I really want, I can just hit the run button on that just to run that zoning data. So the zoning data gets read while I start adding transformers in there. But of course, it was so quick that in the time I was talking, it already did read the data, but that's fine. Okay, we need the spatial join transformer. A spatial join is a way of joining one set of data to another. If you're a non-spatial person, think of it like you're joining data from one database table to another database table. In here, we're just doing a join from one layer of data to another, but it's not just a join on an ID number, it's a join on a spatial relationship. We want to find out which addresses fall inside which zones, and often this is called a point in polygon join. So grab the point on area overlayer transformer that's in the transformer bookmark below, drag it into the spatial join folder, which is the bookmark, which is a little bit small, so I'm just going to expand it a bit. And we need to connect the data up. So what are the point features? Well, the addresses are the point features. So we want to find this information out before we go into the counting. So we want to redirect this connection from the sampler into there. So what I'm going to do is I'm going to click on that and I'm going to drag that connection across and say, yeah, just drag it over and connect it to there. Another way of doing it will be delete that connection and just add a new one. It doesn't really matter which way around you do that. And the other connection is from the zoning data, which is polygons, into the area. Polygons, areas, call them what you will. We can see what they are because we can click on that zoning feature type. Because I've already run it, I can see the visual preview and I can see those are polygon features like so. So we're doing a point on area overlayer. We're overlaying the points, the address points into the zones to find out what zone they belong in. How do we record that information? Well, we have to open up the point on area overlay parameters. We open up that dialog. Let's look down the bottom where it says attribute accumulation, and I put a checkbox against merge attributes. So that's what we're going to do there. So we're basically saying find out which zone each point falls in and attach the name of that zone as a new attribute to the address. So that's what we've got. Now, you'll notice there's a rejected port on there and it's live. So if anything was rejected, well, that would stop the translation and we'll have to consider that. But for now, we'll just leave it. Let's just run that translation. I'm just going to click on the point on area overlayer, hit the run button. And again, this is incremental. We're just trying to figure out if it's working or not. Let's inspect the point features. I'm going to open up the data inspector again. Here's my point features. If I click on one of those, what I really want to know is, does it have a zone number? Yes, it's RM5, which is a multifamily zone. Great. So by inspecting the results of the point and area overlayer, I know that it's worked. I know that each address now has the zoning type that it falls in, whether it's residential, industrial, commercial, or whatever. So we've got that information. The next step is to say, well, okay, we know what zone it falls in. How do we make it so that how do we calculate the number of people in that zone? Well, what we're going to do is some sort of attribute mapping, but we're going to do it with a transformer, the attribute manager, and we're going to use it with a bit of functionality that we haven't covered yet. In fact, we don't cover it until the advanced training, but we're going to use it anyway. And luckily it's already set up, so we don't have to worry too much. Okay, so what I want to say is if the zoning name begins with RS, it's a single family zone and there are 2 residents in that address. Begins with RS, so it could be RS1, RS2, RS3. We don't know, we just know it begins with RS. And that complicates things a little bit. Anyway, so let's put this attribute manager, drag that up into the calculate residence bookmark up there, and connect the point features from the point and area overlayer to that attribute manager. And let's look at that attribute manager and see what it's doing. So let's open that up. Well, we've got an attribute at the top that's been created. It's called persons. And hopefully you're familiar with creating attributes from yesterday. So we can create an attribute and give it a value. In this case, it's got 6 possible values. How do we do that? Well, we do this conditional setting. If we click on the drop down and say conditional values, we've shown a list. So basically this is predefined for us because we're still in fairly basic mode, and this is a bit more complicated. But you can see there, we say, well, if the zone name begins with RS, then it's 2 people. If it begins with RT, then it's 4 people. RM is 12 people, and so on. So that's how that is working. Basically, we're creating an attribute, and it's got 6 possible values depending on a bunch of tests that we set up already in advance, just to make it a bit quicker and easier for us. And yeah, conditional values, we'd cover them in the advanced training in a bit more detail. So if you want to learn more about it, look in the advanced training and see what you can, and then you'll learn about that. Okay, so we now know how many residents there are per address, and we could connect that up, but that's not actually affecting the output. Nowhere in this workspace so far is that number being used. We've got 500 addresses, but we don't know how many. We know how many people are at each address, but we're not doing anything yet that will affect that. One of the ways we could do this is to say, well, instead of having a single point representing an address, let's have a single point that represents a person instead. In other words, if there are 2 people at the address, we need to have 2 points. If there are 10 people at the address, we should have 10 points. How do we do that? Well, we have a transformer called the cloner. The cloner transformer is a way of creating multiple copies of any particular feature. It's one of those you don't use all the time, but it's worth being aware of just for occasions like this. So I'm going to drag my cloner up, and the little tip here, just in case you haven't seen this before, as I drag a transformer, you'll see a little green arrow appears on the left-hand side of that, top left. And if I drag that green arrow over the connection I want to put this transformer in, let go, and it drops the transformer and connects it up all nice and neat for me. So if you weren't aware, yes, FME can do that. So again, I'll just show that. I drag the cloner transformer, the little green arrow appears, I drag it over the connection where I want it, I release the button, and it drops it nicely into that connection. Okay, so we've got a cloner transformer in there. The cloner is going to create a number of copies. Let's open that up. How many copies? Well, it's going to create one. Again, that's a fixed number. We don't want a fixed number. We want to clone it by an attribute, which is the person's attribute, i.e., if there's 10 persons in that address, let's create 10 copies of that address, like so. So we basically what we've done there. So in the original exercise, we took our addresses, we split them up into 5 groups, and we could see that it was split up in 5 groups quite nicely. But then this exercise, we said, well, actually, we don't want to group by address, we want to group by people, because obviously people, there's more garbage being generated, the more number of people there are at any particular address. So what we're going to do there is add the zoning data so we know what zone each address falls inside. And then according to the zone, we're going to create a number of records. So if an address comes in, it falls inside a single family zone, we're going to create 2 records. We're going to create the number 2 and then create 2 records using the cloner, and that will affect the number of addresses that come out. In fact, if I run up to the cloner, you should see, oh, we've got a rejected feature. So something's happened there. We'll just finish this exercise, by the way, and take a break because we've been going for over an hour now, so we'll do that. But I want to get this exercise finished off. So the cloner came up with a rejected feature. Well, we talked about rejected features. The transaction failed. Why did it fail? Well, we can look in the log window. It's always important to look in the log window to see what message came out. Termination message, cloner output a rejected feature. Let's see, why did it do that? We scroll up there. Below feature causes translation to be terminated. It terminated at the cloner. The cloner was creating people copies of the data. What's the value of persons in there, or people, or whatever it was? Oh, there is no attribute called persons. Why is that? Well, maybe that address wasn't actually one that we covered. If you look in the attribute manager and if you look in the manual, let me just scroll back up a bit. We said if the name begins with RS, the zone name begins with RS, it's 2 people. If it's RT, it's 4, blah, blah, blah. And anything else, there is no action. So in other words, if an address fell inside an industrial zone that begins with letter I, while there'd be no action would be taken, it would have no person's attribute. There would be no value to multiply it by in the cloner. So that's what the cloner's complaining about there. The cloner's saying, well, you sent me this feature, you told me to create person number of copies, but there is no attribute called person, so I stopped. Or rather, I rejected that feature, and because we have the terminate option turned on, that caused the translation to stop. So there's a few ways we could address that. We could go back to the conditional values and say, well, actually, if it's not one of our known zonings, we could set it to just 0 instead, instead of not having a value. We could set the rejected feature handling to continue, which would work because that would just continue the translation. But if we do that, then every single rejected port gets the same treatment, and we're not quite sure yet whether we're at the stage where that would make sense. Other rejected ports might still reject data for some reason that we don't know about yet. So I don't want to do that. So what I'm going to do is use this mixed mode that we talked about. I'm going to leave it in terminate mode, but I'm going to handle the copy of the rejected feature of the cloner. How we're going to do that? Well, I'm going to right click on the rejected port, and I'm just going to attach it to a transformer that will just do nothing with that data, really. I could connect it to the inspector, but I don't want to inspect it. I already know what's going on. I could connect it to a logger, but that, again, it makes the logger longer for no particular reason. So what I'm going to do is insert a junction transformer, and basically that's going to say send that data to that junction, and from the junction it just disappears. It's not connected, it goes to nowhere. It's like writing it out to dev null on a Unix system. It just disappeared. It's gone. So that's what we're going to do there. And because we're handling that rejected data now the cloner's not going to have a problem. We run up to the cloner again, and it should be just fine, but it isn't. Why isn't that working? It failed again. It can't be a rejected feature. Well, that shouldn't be a problem that it output a rejected feature. That's better. I don't know what the problem was there. Anyway, you can see now that we took the 543 addresses, we found out what zone they were in. If I click on the attribute manager, I can see that there is a person's attribute that says how many people are in that address, 12, 2, 4, 1, whatever. Then we clone it by that number. You can see that we actually have 2,377 features coming out of there. In other words, that's how many people we've got living at those addresses, or an estimate of those people. And 97 records were output and dropped. Why were they dropped? Well, because they are in a light industrial zone, comprehensive development, historic area, light industrial. So then really not things that are going to have people living in there. Although I did see a multifamily one go past, so that just shows you really should check your data now and then, just for things like that. FM1, we should have handled that, but we didn't. So there we go. Yeah, for some reason I was still getting that. Somebody mentioned here that they were getting the termination message again. So did I. So what I did, I pressed the F5 key and ran that translation again, and it seemed to handle it okay at that point. So if you just press F5, it should be okay. If you run to cloner, for some reason it didn't like that. I think that must be a little bit of a bug, if we can use that word in FME. Okay, so we wrote that out. We wrote it to the aggregator. I didn't do anything. I got rid of that feature color setter, so I'm going to set the colors again just for the sake of it. Again, I don't really need to, but I'm going to do it anyway. Group ID, just so we can see what the groups are, because obviously the groups are going to be slightly different this time. So we've got our data there. Again, I'm going to fire it up in here, and we can see 5 different groups, 5 different colors, and they're sort of looking a little bit better. Well, they're certainly different to what they were, because before we were just treating one address as one person, like so, whereas now we're getting a slightly different pattern, not hugely different, but it is different because we're not creating a single, we're not treating it as one person per address. Okay, now we're going to write the output. Simplest method is to connect that up to the output feature type. So I'm just going to connect that up. You'll probably just connect the aggregator up. I've got this feature color setter in there, so that's getting written to the output. It's a Geo package. I don't know if that even supports color anyway. So now the one thing we should be aware of is the Geo package writer is a type of database. Basically, it means if we write some data there and then write some more data, it'll just keep getting added to that table again and again, because it's like a database. It's not deleting the file every time, it's just adding to it. We don't really want that. If we run this 4 or 5 times as a test, we don't want to keep adding data again and again. So how am I going to stop that? Well, if we look in the navigator window where our writer is, we open up the parameters dialog, or the parameters section, overwrite database, set to no, double click that, check that box, that sets it to yes, and that's great. So every time we run this now, it'll overwrite that file every time. And that was just step 7. So there was a question, got 97 features that ran to the insert junction. Yep, that's right. 97 features got written out to there because the cloner rejected them. The cloner rejected them because it didn't have any number for it. It was a zoning type that we hadn't accounted for because industrial people live in an industrial zone. We are talking residential garbage, not industrial. So we ignored that. The cloner said, okay, well, I'm going to reject it then. And it turns out there were 97 records like that. If I close the program because Workbench just died, that's okay. I'm going to start it up again. And we're very close to just taking a break now. I can open up that previous workspace and it should have saved the backup file for it. So what are we on? We're on design exercise. It was exercise 1 begin. I was still using the same file. This is a fantastic example why you might want to version your workspaces just in case something happens. And that didn't look good. I must have clicked the wrong button somewhere. Let's just go to design exercise 2 complete. And it looks fine like this. Let's see. You can set your else statement in the persons to 0. Yeah, so in the attribute manager, what we could have done is gone into here and said, if it's not one of those zones, set it to 0, and that'll be good. The thing with that, I wasn't sure what would happen with 0 copies. Does the cloner just leave the copy that comes in, or does it output it, and so on? So I just basically didn't want to do that because I wasn't sure what the cloner would do. I guess I could have set a test up to do that, but I didn't. The other thing that's nice about doing it this way is the cloner writes it to this junction and it actually tells us you have 97 features got rejected, and we wouldn't have known that otherwise. So we know there were 97 features that were an issue, whereas if we just set that to 0 in here, I probably wouldn't know that there were 97 rejected features. So if it was important for me to know that, yeah, so it worked okay. We only got the same number of features out. We just didn't get the rejected features, which is good. But on the other hand, I don't know how many features went out. So anyway, that was one reason why I didn't change it that way. But like you say, this was a question that came in. Like you say, we could do it either way there. I quite like this exercise myself. And when we get to the final part, we really get a nice output from this. What we're going to look now, though, is some testing techniques for a workspace, because we've sort of looked at a few of those already, but we've not really looked at them formally. We've just used a few in the exercises. So I'm going to look at and explain some of the different techniques for testing. One of the things we do, not just in testing, but in authoring a workspace, is something we call a partial run. A partial run is when only one section of a workspace is carried out. Now, we've been doing this over the last couple of days anyway, so you probably know a lot about this, but we'll mention it anyway, because one of the ways that we haven't looked at is to disable an object. I'm going to open up another workspace just so I can demo something to you. You don't need to follow along with what I'm doing here. I'm just opening up, oops, I'm in the wrong place, what my instructor workspace is, and 310. Okay, so I got a workspace here, and say I just want to run part of it. Well, how can I do that if I just wanted to run this section of it? Well, what I'm doing is I've got these other objects disabled. Because they're disabled, they won't pass any data through. This connection's disabled, no data is going to go out to there or there. So when I run this translation, it should just run that top section of Workspace, and that's it. And that's a great way for me to just run a bit of an existing workspace and test what the results are. Now, how do I disable something? Well, you can right click on any object and you should find that there is a disable object. Disable, enable, Control E is the shortcut for that. And that's the one I tend to use quite a lot. So you just find what you don't want to run, you press Control E and it grays it out, and that won't get run now. So yeah, so if I just wanted to test this bit with Public Art, Vertex Creator, Reprojector, I could say, well, actually, let's disable the park so they don't get run. Disable the point and overlay or the connection into it, because otherwise it'll start complaining about things not working, and then just run that translation again, and it'll just run this little bit now. So you can disable different components inside your workspace, and it lets you just run part of that workspace. So that's one way of doing a partial run. Another way of doing a partial run is, as we've seen before, just to click on the transformer that pops up and say, run this bit, run that bit, and so on. Partial runs, so why are they important? Well, because you can develop your workspace incrementally, so test a bit at a time, but it's also useful when you've been given a new workspace to you. Like someone had created a workspace, often they leave the company to go on bigger and better things, and you've inherited all their workspaces and you're like, I don't know what it's doing, or now it's failing and I don't know why. So what do you have to do? Well, you can disable part of that workspace and run a part at a time to figure out what's going on and where. So these are the reasons why you might want to do that. Another interesting thing about these feature caches that we should mention is that you can actually save your workspace with those caches attached. You can click File, Save as Template, and what that does, it saves your workspace as this .fmwt file. Normally it's just a .fmw file. This has got a T on the end for template. And all it really is a zipped up version of the workspace file. And it includes all of the source data that's you're reading. And you can also check the button that says include feature caches. So what I get now when I do that, I should find that I have this, where is it? It should be a .fmwt. It's hard to tell which file is which. There it is, that one there. So design partially runs disabled objects.fmwt. You can see it's 4 megabytes compared to 200 bytes before, because it's containing all the data, because it's containing the caches that I had in that workspace. So you can save the cache along with your workspace if you just click File, Save as Template. And that way, if you run a workspace and it took a long time and it produced some whole bunch of caches, you don't want to lose them. File, Save as Template, and the next time you open that template up, the caches will be there anyway. Question there, is there a way to fill metadata for the canvas as a whole? Yes, if you look in the navigator window again, back at Workspace Parameters, there's this option here that says Name. If I double click that, you can see I can give my workspace a name. So this is a demo workspace for training. We'll call it that. We can give it a category even. So I can say, well, this falls under one of these existing categories, or I can create a new category called training, under which these workspaces will go. I can give an overview of this workspace. This workspace creates data, blah, blah, blah. I can do some help functions in there, like you need the parks data set. And there's even a history field, so I can go into there and say, yeah, this was May 1st, 2019. The user was Mark, and initial creation or whatever, and so on. And so, yeah, so we can fill in metadata there, like the overview, the help, the history. Even the history tells us when it was last saved, what build it was last saved with. So this workspace was last saved on the 22nd of April, 11:34 a.m. using FME 2019 build 19238. So I don't even know what build we're on now. Might be a slightly newer version. Yes, it's 19246 now. So if I save this workspace, actually, because I'm saving in a new version, it asks me, do I want to, and this is an interesting one by itself. It says, well, you're saving in a newer version than this workspace was created in. Are you sure you want to do this? Because you won't be able to go back and open it in that older FME if you just save it. Or you can save a backup as well. I'm just going to say save it without the backup. And now it's been updated and saved in this later version, 1st of May, 1043, which is now for me. So yeah, there's plenty of metadata in there that you can fill out. And that was in response to a question that somebody asked there about metadata for your workspace. The other thing I often do is I put it on the canvas. So I right click, put an annotation in there and say workspace, create data, author, mark, date, whatever. And it's not the same as the official metadata. It's not used in the same ways, but it's there on a canvas and you can see it. So that's another way that you can save information there. But generally, the workspace parameters is the place where you officially create metadata. So yeah. So anyway, that was partial runs. Oh, wow, that was really quick. So we're back into our exercise here. Somebody asks, is Workbench not backwards compatible? Workbench is absolutely backwards compatible, but when you think about it, that question wasn't really backwards compatible so much as forwards compatible, because that was saying, well, like, could I open this workspace in 2019 back in 2017, for example? And the answer is, well, no, I can't necessarily do that because in 2017 wasn't forwards compatible with 2019. So that's okay. That was a question that came through, and that's fine. Yeah, it's just really you got to sort of get your head around that, and it took me a while to think about it. But yeah, when you think about it that way, it's like asking you, could I save this? Do I want to save this workspace as a backup? Because otherwise it might not open in an older version. Well, that's yeah, it's like saying FME 2017 was forwards compatible, which it couldn't be. But generally, yes, FME is backwards compatible. So if you open up if you create a workspace in 2017, open it up in 2019, that'll be fine. It'll run just as it did before in 2017. And you should get exactly the same results as you did then. We're very careful when we update our transformers to make it so that they're backwards compatible, so that what happened before will happen the same again in the newer FME. We really don't want to make things change that much. And sometimes they have to change, but they'll always give a better result. But generally, we don't like to do that. Even if the result would be better, we don't like to necessarily update you automatically, because that will be unexpected for you. So yeah, generally we're backwards compatible. If it worked in 2017, you open it up in 2019, it'll work exactly the same way. Okay, so let's go back to this project that we were working on. We've pretty much done everything. We connected up to the writer. I don't know if we ran it, but we can do that now. We can click on the writer and click run to this, and it doesn't have to do the entire thing all over again because the data was cached up to that point. So that's that was a partial run. That was the shortest partial run you could ever get, really. The question did come up the other day, actually, on Twitter. Like, can I force FME to run this workspace again? Like, if I press F5, FME says, okay, well, I'm going to run this workspace, but if it's cached already, I don't need to worry about that. So it didn't rerun any of that cached part. If I want to rerun the entire thing again, I press Shift and F5, and that shortcut runs the entire thing all over again. You can see it starting from scratch. And if you look under the Run button on the toolbar, you see you've got those two options, rerun or run and rerun entire workspace. And so I just rerun the entire workspace. So F5, Shift F5, those are the two shortcuts. F5 just runs whatever isn't cached already. Shift F5 reruns everything. The other shortcut button is F6. F6 basically says, wherever I'm clicked, run that workspace from that point onwards. So even if I want to, even if that was run already, if I say I'm going to run from the Spatial Sorter onwards, I press F6 and it runs that bit onward. So F6 is the shortcut for just partial run of a workspace. Okay, well, if we look at this data that we're getting out, it's all well and good. We've got all of these points and they're all grouped fairly nicely into spatial groups. But the previous data set had a boundary around it. So we need to create a boundary around that. The hull replacer is how we do that. So we drag the hull replacer up into here, and I'm going to drag it. And like I did before, I'm going to drag it with that little green arrow, and I'm going to drop it onto the connection between aggregator and output. And there it is, it's connected up. Again, you could connect it up manually if you wanted. There's no cache on the hull replacer. Why is that? Well, because it's just been placed. If I just want to run the hull replacer, I can click on there, the pop-up buttons, run to this, run from this. F6 is run from this, Shift F6 is just run to this. So if I click on the hull replacer, do Shift F6, it'll just run that one transformer. And we can see in the output, there we go, we have our zones. These are our basic zones. Now, you can see some obvious problems with that and the fact that they overlap. So if my property was in this area, would I get my pickup on Monday or Tuesday? Like, how would I know? Well, so what we're going to do is we're going to have to decide, we're going to have to sort of merge that piece in with one of the other zones. And we're going to have to decide which zone it gets merged into. So what we're going to do is we're going to say, let's count all the addresses in here, count how many of those addresses fall in this part, count how many of the addresses fall in that part, and see which ones has the most addresses, and then we'll assign it to one of those polygons, depending on which one has the most addresses in that overlap. So that's what we're going to do right now. Okay, so you'll notice that we don't have any more transformers in there. So this is sort of where you get to the point you say, oh, okay, I wasn't expecting that. So now what am I going to do? Now it's one of those things that sort of unplanned. You've got your workspace, you've done it as you planned, and then you say, oh, actually, it needs a little bit more work done on it before we can get any output. So that's what we're going to do here. I've dragged that bookmark just up there, and I'm going to double click on it and rename it Clean Up Overlaps. I could have put a new bookmark there, but I had that bookmark there already, so let's just use that. So I dragged that bookmark up there, double click on the header and renamed it. And all of the work we're going to do now, we're going to start putting it into there. Okay, so what are we going to do? What transformers are we going to use? Well, I know that the area on area overlayer transformer will basically split up those areas, and it will extract the overlapping part of them as separate features. So that's what I'm going to do first. I'm going to put an area on area overlayer transformer in there, and the shortcut, if you're adding it with quick add, is AO, area on area overlayer. You can type transformer names like that. So AO, and there's my transformer. So I put an area on area overlayer transformer down. Let's redirect the output from the hull replacer, which generated the boundaries around the points, into the area on area overlayer. Again, if I really want, I can press Shift F6 and just run it, or even just F6 would have done there. And I can see that, oh, look, those overlaps. Now, if you can see, that overlap has been sort of chopped out as a separate feature. So that's good. Now we just need to figure out which area it goes to. Now it did say, actually, check the parameters and change accumulation mode to drop incoming attributes. The reason we're doing that is because we want to find out which has the most number of points, and attributes would start getting confused. So we just need to set that to drop attributes. That's one of those things you find out through trial and error. And it was my trial and error that led to this instruction going into the manual. So you can take that one as read for now. So we've got the areas on there. Now we need to find out who had the most points in there. How do we find out points in an area? Well, we have the point on area overlayer, which we've already used. We need to do a point in polygon here. Again, this is sort of the trial and error part of the exercise, but so you can just take this as read. And if you don't quite understand why these transformers are being used, don't worry too much about it. It's really the important part is the idea of the workflow and the testing and the running one piece after another. Anyway, so let's put a point on area overlayer down, POAO. This time I can do a shortcut for and add that down there. So these are my area features coming from the area on area overlayer into the area port. Where am I going to get the points from? Well, we'll fetch them from a previous transformer. We want them before they were aggregated, so we'll drag a connection out of the spatial sorter. That's a second connection there and onto the point there. So like you saw yesterday, you can have multiple connections coming out of any particular transformer, and that's all we're doing here. We're creating a copy of the data just to send into here so we can do an overlay and figure out which of the areas has most points in the overlap. And again, you might want to run it at that point. Just run that transformer, see what the results are, look at it in the full data inspector and say, oh, look, let's see what we've got here. So that's the overlap. What does it tell me about that? Well, there were 114 overlaps in there. And so there's 114 points fall inside that overlap in Polygon. And if I can query that bit of overlap, 87 points fell in there. So that's all good. We don't know whose points they were yet, but we know 87 points fell inside there. Okay, so let's have a look at the parameters because I didn't set any parameters up for that. Let's open that up. Again, it's all about accumulating attributes, finding out which points belong to which area here. So we open that setting up. We open up the dialog for the point on area overlayer. Looks like this. We are going to accumulate attributes by putting a check mark against merge attributes. And we are going to put a check mark on this option here that says generate list on output area. Why are we doing that? What is this list? Basically, it's going to tell us a list of which points fall inside that area, and from the ID number we'll know where they came from. So we'll just give the list a name. A list, as you might find out in FME, is an attribute that has multiple values. So we're just saying, let's create an attribute called point list, and it's allowed to have multiple values of, and we select group ID. Where's group ID? There it is. So in other words, overlay these points into these polygons. For each polygon, tell me a list of points that are in it, a list of the group IDs. So in other words, if we've got group 1 and group 2 polygons overlap, we're going to sort of do this overlay and find out which points we're doing the overlapping there. So hopefully you're up to there, and I can just click OK. And we have that transformer set up. And again, I could run that and just query the data to find out, well, tell me what this list consists of. And if I do that, if I query that polygon there and look in the what we call the feature information window, I can see, oh, why does it keep, that is very odd. It won't let me open that window up. There we go, that worked that time. So what it's got this list. It says, well, okay, that was group 2, that was group 2, that was group 2. All these addresses came from group 2. And as we scroll down that list, oh, there's some with group 1. So we can see that the majority of addresses that fall inside that came from group number 2, which I assume is this one, and not group 1. There's only a few in there. So that's how we're doing it. So the point on area overlayer generated this list. We can see this list inside that when we query a feature. So that's what a list is, just in case you were wondering. So a list is one attribute, multiple values. Okay, the next step is what we call a list histogrammer transformer. And again, as it says in the manual, this is not a commonly used transformer. So don't worry about this. You don't worry like, oh, I've got to remember the list histogram, and I've got to remember that. Don't worry too much about that. For now, just take it as read that you need to use this transformer. If you're new to FME, don't worry about it too much. Yeah, it's just a transformer that I know we have to use, and so I'm putting it in this exercise just because it meets the exercise needs. But really, again, the more important thing is using transformers, using them in a sequence like this, running one at a time, getting the result out, finding out where problems occur, that sort of thing, looking back for that, partial runs and all of that sort of thing. So don't worry too much about what transformer is being used so much as how it's being used, how we're doing the partial run, how it's connected. So let's have a look at the list histogrammer. What does this do? Just out of interest. Well, what it does is it scans through that list and it tells me how many records of each number there are. So for example, say I have an area of park with trees in, and there are 100 different trees and they're varying varieties. So I've got this list of 100 different trees. I've got oak, elm, oak, cedar, elm, ash, pine, oak. That's my list. What the list histogrammer does, it counts through there and says, okay, I've counted through that. There were 20 oak trees, 5 elm trees, 35 pine trees, and so on. And so what it's going to tell us here is, well, in this overlap, 30 addresses came from group 1 and 2 addresses came from group 2. Therefore, this section of area of Vancouver should be incorporated into the group 1 area. So that's what it's going to do for us here. So what we're going to do is say, look at this point list group ID and create a histogram of that. And if I run that now and look at that list histogrammer results, it's going to say, yeah, here's this part of that, and histogram value number 2, there were 110 addresses that fell in there that belong to group 2 and 4 addresses that belong to group 1. So it's really quite clear that that section should be merged into group 1. I've got no idea why it's doing that. Every time I move away, it shuts that window off. So we will have to make a note of that, I think, and talk to the developers about that. Anyway, so that's what the list histogrammer does. What have we got to do? Finally, final step is to dissolve those areas back together. There's the dissolver. Dissolver basically merges bits of polygon back together again. So we've got a whole bunch of polygon geometries. We're going to merge it back together again, but we're going to use the group by, and we're going to say group by the most common value that the list histogrammer found for us. So hopefully now you can see where this is going. We said, okay, split our overlaps up into pieces, find out all of the different groups that go into that piece. List histogrammer finds out which one the most common is, and the dissolver is going to dissolve it back together using that value. So in the dissolver, we click the button, look at the parameters, group by. Under histogram, we want histogram value, like that. In other words, find out which group was the most common, and we will dissolve our polygons together by that. Click OK, run that bit, and we should find that we now have our groups. I'm going to turn off the remnants because we don't need those. There we go. We have, that's group. What group is that? Should have an attribute. That's group number 2. Actually, it doesn't matter what the group ID now at that point is. It just matters that it, because this is one of those things where attributes are starting to clash, and we've got duplicate group numbers like group 4 and another group 4. That's because things got copied over a bit in those overlays. It doesn't really matter what the group number it ends up with is. It's more important that we have the right shapes now, and they've all got a similar number of people in that shape. So you can say that a lot of people live in this area and this area because it's quite small. Maybe fewer people live in this area because I don't know why. Maybe just fewer people live there. Maybe it's less dense. I'm not sure about that, but maybe that's more commercial than residential there. So that's why that area is bigger. So that's our result. And all I really need to do now is connect that up to the garbage zones output and run it, and we're good to go. Oops. Yeah, so that was the output. Now remember that we're still in what I would call authoring mode. So we need to go into our final production mode really, and run this without the sampler in there. Somebody just asked, how do you open the inspector directly instead of the visual preview? Okay, so there's 2 ways of doing that. One of the ways is to say, to browse something in the visual preview, and then there's a little data inspector button on the left of the visual preview that says, basically what I'm saying here is I can't see that, it's too small, so just click this button and open it up in the full data inspector for me. So that's one way of doing that. That's the way I normally do. Today, really, because I'm doing so much outside of the visual preview, what I could do is close that visual preview window down. Now if I query something, it'll just open it up again, which isn't really what I want. So I'm going to close that window down. I'm going to hit Tools, Options, and under Workbench, there is an option here that says Inspect with the Data Inspector when the visual preview window is closed. So I'm going to click on that button there like that. What that says is, well, if the visual preview window is open, then fine, use that. But if it's closed and you inspect something, then open it up directly in the data inspector. So we have these 2 ways of looking at things, and you have complete control over how that works. So again, Tools, FME Options, this option here, it says Inspect with Data Inspector when Visual Preview window is closed. As long as that window is closed, anything I do with an inspector transformer or visual inspection in there will go straight to the data inspector. But if I have that window for Visual Preview open again, and I query something and inspect it, well, it'll go back into the Visual Preview window because the window's open. So if you don't like that at all, you can shut that window down and have it go to the inspector. If you do like it, you can do it. You can show it here. You can click the inspect button. That'll open it up somewhere into the inspector directly, or you can shut that Visual Preview window down completely. So there's a whole bunch of ways we've got to handle that. The other thing that's quite useful as well is this button in the top left of the Visual Preview. That's what we call the automatic inspect. Because some folk have said, well, I like having the Visual Preview, but what I don't like is when I click from the dissolver to say the hole replacer, everything updates. I don't want it to do that. I want it to stay in the dissolver. How do I do that? Well, the little button on the top left of the Visual Preview turns off. It's basically locking the view, I guess. So now if I click on the Spatial Sorter, the hole replacer, the area, whatever, nothing changes in that window because I've locked it to the dissolver view. If I go back and turn that option back on again, now when I jump about looking at different things, it opens up differently in the Visual Preview. So you can actually lock that view down to a particular transformer. So yeah, so now, like I was saying, really we've got to get through, we've got to sort of come up with this idea of authoring mode versus final production mode. In production mode, you don't want the sampler in there. So I would say, let's delete that sampler transformer. In production mode, I would probably turn off feature caching because I don't want caching on. I want it to make sure it always reads that first data set, those data sets fully every time I run it. So now I'm in sort of production mode. I can save the workspace, run it, and it'll run that translation, and it won't sample the data this time. So now it's going to take a little bit longer because it's not sampling the data. But on the other hand, it's going to be a little bit quicker because it's not caching it as well. So we're sort of in production now. We're saying, well, I don't need to cache it because I'm confident that everything is going to be fine. And I don't want to sample it because I want to get the full true result out, please. And the Visual Preview window shouldn't make any difference here because we're not got caching on, so it shouldn't be an issue. So you can see it's taking a little bit longer this time, but now it's finally getting through. List histogram of 3 features, 4 features, 5 features, dissolve them together, and oh no, 8 features, 9 features. There we go, because we were overlaps. I forgot about that. There we go. Let's look at the garbage zones, the output. Let's look at them really in the data inspector, and that's our final output. And you can see how, well, that was with the sampled data, the final data looks like this, which is a lot more realistic for us. So really the sampled data was great for us to get our method together, but when we ran it in production mode, we found that the result was quite a bit different, quite a bit more useful. So if the city of Vancouver is watching, this is what you might want to change your garbage collection days to, because they have a roughly equal number of people inside each of those zones. So we've done that. But again, it's great to show you examples like this. It's great to show you the things FME can do and it could be used for, and how you could do garbage pickup zones with FME like this. But really what we're trying to get across today was all about different workflows and how to create a workspace a few steps at a time, putting together that workspace, running it bit by bit, running it in an authoring mode, if you like, checking the caches every time, making sure everything's working okay. Finally finding out, oh, well, there was an extra bit we had to do that was a bit off the cuff, but that's okay. These things happen. And we basically ran it and everything was fine. We can get rid of that inspector. We don't need that. And we're in production mode now. We ran it in production mode. The results are good. We got rid of the sampler. And so that's really what we're trying to show here, is how do you put a workspace together? And if the garbage zones or any of the individual transformers in here resonate with you in a particular way, that's fantastic. I personally like the hole replacer and the spatial sorter and all of those transformers, but really familiarization with those transformers is a secondary objective to learning about the run from here, disabling feature caching, disabling different connections in a workspace, partial runs, all of those things are what we're trying to show here today. So there is some other content I would like to show. Before we do that, I just want to go and ask you in a poll, did we present the material today in at the right speed, a little bit too quickly, too slowly? Let us know what you think about that. I like somebody's comment now was, if only collection sectorization was so easy. Where's the transformer that modifies the union reps and crew chiefs? Yeah, I guess exactly that. And politicians as well. I mean, you could use the same sort of functionality to generate election boundaries and say, yeah, let's subdivide our state or county into different electoral districts. But yeah, you'd probably get quite a few complaints from the politicians who it didn't work out for, or not from the politicians who it did work out for. But for me, that's a good way as any to avoid being accused of gerrymandering, at least if it comes up in a sort of algorithm like this. But anyway, so that's the sort of things you can use it for. But yeah, there's always the people factor, and people always complain about the results like this, I guess. But anyway, so thank you for your feedback on the speed. So I went through a little bit quickly today, so apologies for that. Is there anything I need to cover before we recover and sort of look at a game before we go on to another bit, or are we, even though I did go through it a bit faster, we're pretty happy with what we've got and where we are so far? So let me know in the chat window and the question window if there's anything I need to go over again before we sort of go on to the next part. But I'm not seeing anything coming through, so in that case, I think what we'll do is, let me just see where we are, because I know we finished this chapter, but really the first part of the next chapter is quite related to what we covered today. So if we can sort of cover that now, it would save a lot of time tomorrow. So that's what I'm going to do then, since we've had no comments. So I'm just going to, for the last 15 minutes of today, I'm going to look through the bit on workflow transformers in the next chapter. Natalie suggests we look at the final exercise. I don't think there is a final exercise for this chapter. I think we pretty much did everything there, so there's no more exercises to do in that last chapter. So what I'm going to do is I'm going to skip through to the next chapter, which is practical transformer use. And in particular, I'm going to go to this section on workflow transformers. And I'm just going to talk about these. I'm just going to chat the link out so you know where I am. And we're going to talk about these. I don't know if there's an exercise to do or not, but it really relates to what we've been doing, and it will save some time tomorrow. So workflow transformers. Let me open up a workspace that will help me illustrate some of this. Instruct to use. What chapter are we on? There's some got funny numbers on there that shouldn't have, but feature readers and feature writers, I think, yeah, that'll do. So what we're going to look at here is some workflow transformers. because we've been looking through workflows today and building workspaces, and what we're going to look at is transformers that help us do that. Like if I want to do something before I read the data, or I want to do something after I've written the data, how do I do that? Well, we have a couple of transformers called the feature reader and feature writer. We also have these transformers that connect to web services like the Dropbox connector, the Google Drive connector. We've got transformers that will read and write attributes in and out of files mid-translation. And there's also transformers that will send and receive data packets in the middle of a translation, like the TCP/IP receiver and sender. So for example, one of the projects that I know one of our customers did was lightning detection. And basically they have a workspace running that has this TCP/IP receiver transformer in there. And basically that transformer runs and continues running until you stop it manually. And what they have is they have a whole lightning detection system all over Canada and North America. And whenever a lightning strike occurs, the detector picks it up and it pings a message to TCP/IP. FME receives that message and processes the data and say, oh, there was a lightning strike at this location, update our maps, send alerts out to people, and so on. So the TCP/IP receiver can listen for external input over a TCP/IP channel, or there's SQS or JMS and all sorts of different ways of receiving information from outside on a real-time basis there. So that's one thing you could do with FME, but I just wanted to mention that one in particular because it really is an interesting idea. But what I want to look at really now is this feature reader and feature writer transformer. And what do they do? Well, the feature reader basically reads data instead of a reader, and the feature writer writes it instead of a writer. So looking at this first example at the top, this is what we can call a plain example, really. So a feature reader transformer, it's reading the map info data, it's reading the parks data, and that's all we really need to know here. Now, it does need a feature coming into it to kick it off, to initiate that process. And here we have a creator transformer. Creator transformer just creates as a feature. So we're creating a feature, sending it to here. The feature reader says, oh yeah, I'll read that data. And then we send the data to the output. So if I make sure that we have feature caching turned on again, I can just hit the run button. Okay, you'll see that this created a single feature. It sent it to the feature reader transformer. The feature reader said, oh yeah, I'm set up to read the parks data. So it read the parks data. There's my 80 parks features, and we see them in the visual preview at the bottom. So that's basically what a feature reader transformer can do. And the nice thing about that is that you can do other things before the data gets read. So you could say, well, I might want to put a transformer in here that does something else, like a SQL transformer. Like I want to run a piece of SQL code before I read that data into the workspace. Like I might do something to that parks data while it's still in its database or its file or wherever it is. So I can do sort of things like this. I can say, actually send an email out to somebody saying, hey, this is from me, this is from FME, and the body of the message is, I'm about to read parks data. So we can do things before the data is read, whereas with a standard reader, that's always the first thing that happens. So this is what we can do with the feature reader. Now, the nice thing about the feature reader is that you might say, well, why does it need a feature to initiate it? Like, can't it just start itself? Well, it could, but the other nice thing that it does is this. It can actually take a whole bunch of features coming into it and do a different action on them. And why did that fail there? Oh, it's looking at the wrong folder. It should be looking at 2019. So let's sort that out. So here, for example, I've got an orthophoto catalog. What does that mean? Well, I've got basically a grid here. Let me open this up in the inspector. I've got a grid of files here, or a file with a grid of features in, and each feature has got a name. So it's a name of a grid square. So this is 0405PQ. This is 0607PQ, 089PQ, 1011PQ. So you can see that each of these has got a number to it, but it also points to a file that exists. And in this case, it says, okay, well, this is related to FME data 2018/data/orthophotos 10-11-pq.tiff. Now I can see straight away this is not going to work because that's still pointing to the old file 2018 when it should be 2019. So we have to update this data set, and we'll do that now that we've noticed that it's out of date. But what would normally happen is you say, go into the feature reader, read GeoTIFF, and the GeoTIFF file I want to read is the attribute image file, which is coming from that source data set. So in other words, I'm reading a catalog of files. The name of the file is stored in this attribute. Then I tell the feature reader, hey, read that file. So now if I hit the run button in here, it'll run that, it'll read all those files, it'll go into the feature reader, and that's where it will stop because it will say that file doesn't exist. But if it had the right path name, it would. So that would be a way to say, read all of these features out of my feature catalog. Or what I could do is I could say, put a tester in here and say, okay, only read all of the files that end with PK or whatever that grid number was. So now I'm just saying, well, read that catalog, read only the PK column of files, and then read all of those raster files in directly. So that's the sort of thing we can do. It's a bit more advanced with the feature reader. It lets us chain these different reading operations together. So the data set to read is basically coming from an attribute, which is useful. The other final example I want to show on there is to say, well, there is a spatial filter option on the feature reader as well. So what I can do is say, well, I'm going to read the parks data. So here's all of my parks. I want to find all of the addresses in the city, that fall inside a park. How am I going to do that? Well, I could read the parks, I could read the addresses, I could put them into a transformer and do an overlay, and that's all right. But the other way of doing it is to say, let's read the parks, send them to this feature reader, tell the feature reader, read the addresses database, but only read it where this spatial filter occurs, where the initiator, the park, contains the result, the address. So in other words, send the parks data into there, read the addresses, but only read them where they fall inside a park feature. And if I run this translation now, you can see we read the 80 parks. It's sending each park one at a time as a query to that database and saying, hey, pull me back the addresses, please. And somebody said as a question or a comment, feature reader is sort of best practice when it comes to inputting features. Well, yes and no. I mean, what really scores highly in this case is that we're reading from a database. So like I said before, you could read all of the parks data, you could read all of the address data, and then you could do that overlap using an point on area overlayer inside FME. But what the feature reader does for us, it does a query. So we're not reading more data than we need to. It's not reading all, I don't know, 15,000 addresses in the workspace and then doing an overlay. It's only reading the 50 or 60 addresses or whatever it is that actually fall inside the park. It's not having to read the entire data set. So it's a way of doing your spatial query in the database itself and only reading the data that you need. It's sort of like and the analogy I like to use is think of it as a menu for a restaurant. It's like if you order all of the food in the restaurant without looking at the menu and say, okay, that's okay, I'll pick on the table when it comes. And all the food in the kitchen comes to you and you say, yeah, I like that dish, I like that dish, I'll eat those. But it cost you a fortune because you had to order all of those dishes and the time and the expense of that. And that's like reading all of your data as well. Whereas the feature reader is like looking at the menu and saying, actually, I only want this dish and that dish. And so only cook those and it's cheaper and quicker. And so that's what the feature reader is. It's really this menu. It's saying, pick me the addresses out, please, but only the addresses that fall inside the parks. And so it's able to do that a lot quicker than reading everything all at once. And so we find out there are 74 addresses that fall inside a park, and that will be quicker because we're using the database for that. The feature writer does the same thing, except we are just writing data instead of reading it. So here's my feature writer examples. And again, the feature writer is nice because you can do things after you've written the data. Normally in an FME workspace, the writer is the thing that comes last. Here we can now say, actually, the writer doesn't come last. We can do things after it. For example, here, I'm reading the parks, I'm calculating the area of the parks, I'm dividing it up into small, medium, and large parks, and I'm writing that out to the feature writer, which is saying, basically, write my data out to these 4 different layers, small, medium, large, and extra large parks. So I can run that workspace, it's run it up to that point, and it's writing out to GML. So if we look at the GML output from that, we can see that there are 4 different layers and they've got a different number of parks on them. And so we've written the data out just as if we had a writer. But what we can do then is we can do other things, like the summary can go to an emailer and say, hey, I've updated the parks data set. So every time I run this workspace, it sends a message from FME to my administrator saying, hey, I've updated this data set now. Now it's ready for use. Or if it was a public data set, you could use a tweeter transformer and say, so you could say, hey, people who follow me, who use our open data, the parks is updated. And I get this from the City of Vancouver. I get like emails every so often saying their open data has been updated. I don't know how they do that, but they could do it like this. They could say, run it from FME. Every time you write the data, send a tweet message out saying, hey, the parks have been updated, just in case you wanted to know, and send that tweet out or send the email out or whatever. So in other words, the last step is not the writing of the data. The last step is what we choose to do after that. And in this case, we're even actually following up with another feature reader. So we're saying, well, we split the data up into parks, into small, medium, large, etc., and wrote it out. But now I also want to find out what addresses fall inside the park, like we just did. And then I want to write those addresses out as well to a separate data set. So now we're chaining a creator to kick. No, actually, we're chaining a reader here, then a feature writer, then another feature reader to read some different data, and then a final feature writer to write it out. So that's what we can do. We can read, write. You can do all sorts of things with that. And so I wanted to cover that because that really covers a lot of, it's very related to what we covered today about generating a workspace and workflows and design of workspaces. The other one, which I don't think we have an example of, well, actually, we showed that already using the emailer and the tweeter account, tweeter transformers in that previous workspace. We can put transformers in there to read and write from web services. So, for example, when I'm reading the public art, I could do something there, reproject it. I could write it to Dropbox. I have a Dropbox connector transformer. So I could say, actually, it would probably come after a feature writer. So I would say, give me a second. So we've got some artwork, we've reprojected it, we write it out to a file, and we take that file and we upload it to Dropbox using my Dropbox account and uploading that file, or even load up the contents of an attribute if we really wanted. So we can say, write that data out, upload it to Dropbox, send an email out, send a tweet out, basically doing all of these things after the data has been written. The data is written mid-flow. The other nice thing about this as well is we can read data from a web service somewhere. So we can say, I'm reading that parks data, map info, but what I want to do is select it from a web page, and it's stored on Dropbox. So take me to Dropbox. Here's my Dropbox connection parameters. Find the tab file on there and read that. So we could read, FME can read directly from Dropbox. It can read directly from ProjectWise, Box, Server, Google Drive, OneDrive, all sorts of things. So yeah, I know folks have probably got things to do, and I'm going to stop any second now. I just wanted to mention these because they will come in useful. Yeah, and that's pretty much it for today. The one final thing I wanted to mention was that you can copy a URL and paste it into here. So if I knew the URL directly, I could say, read this from safe.com/downloads/file.tab, and it would read that directly. So there you go. Okay, so excuse me. So I think we're done for today. So we'll let Ryan know that he doesn't have to cover this section tomorrow because we looked at it today. But the feature reader, the feature writer, fantastic transformers to be aware of. Yeah, so please make use of them, especially in workflows like this. They let you do things before you read data and things after you write data. And we have transformers like these connectors and emailers and the FTP, not the FTP, the TCP IP, although FTP as well. We've got things like this where we'll receive and send information over a network like that in a workspace, again, which can be very interesting. So yeah, so there we go. So thank you for attending today's training. Apology if we went a little bit fast earlier, but hopefully you can go back over the content later perhaps and read up on anything that you might have missed out, or send us a question to train@safe.com, and that's all good as well, and we can help you out there for sure. So tomorrow Ryan is going to cover the transformers section of here that we call, what do we call it? Practical transformer use, that's it. And then on Friday, it's going to be Sam and myself will be online for best practice, which is quite a useful functionality as well. So please do come back for that. I know it's Friday, it can be pretty late for some people on a Friday, but it's a nice chapter to do. Anyway, so I will stop talking now and turn off the webinar. Just again, thank you for attending today. It's been great doing this chapter. I hope you learned something from it and it was useful for you. And